Awesome. Well, remember whenever you have a rational exponent, that's basically like a radical. Remember, it's power over root. Anytime you have that rational exponent, so if I have x to the 3/5, this is the power, so it's x cubed, and then the 5 in the bottom represents the 5th root. So I could rewrite this as the 5th root of x cubed. So really, when you have a rational exponent, you're really just solving a radical again. But because it's in exponential form, we can use that to solve this. So now I'm going to take this to the 5/3 power. Whatever you do to one side, you have to do to the other. And notice whenever you multiply fractions, the 3 on the top cancels out the 3 on the bottom, the 5 on the top cancels out the 5 on the bottom, and that's why we take it to the reciprocal exponent. Because whenever you power to a power, you multiply, and then those cancel. Now I'm left with 27 to the 5/3. You can rewrite this as the cube root of 27 to the 5th. Well, remember, you always want to break down your radicals first and then take it to your exponent. So the cube root of 27 here is 3, and 3 to the 5th power is 243. Cool. All right, here we have another rational exponent problem. So we're going to take this one that's x minus 4 to the 2/3 power. Now, here's the deal on this one. Whenever I take this one to the reciprocal power, that is 3/2. Whenever I take 3/2, that 2 in the denominator is a square root. Now, anytime you make a square root symbol, what do you have to write? Plus or minus. Exactly. So what I'm really doing here is plus or minus the square root of 16 cubed. And what's the square root of 16? 4. So this is plus or minus 4 cubed, and 4 cubed is 64. So now when you add 4 to that, remember, anytime you have your plus or minus and you're adding 4 to that, that goes in front. So essentially we have two answers here. X is equal to 4 plus 64, and x is equal to 4 minus 64. So x is really equal to 68 and a negative 60. Very cool. So for this particular problem, you have two answers. Nice. All right, here's an equation in quadratic form. Remember, quadratic means you have a squared term. Well, look at this one. It doesn't necessarily have a square term. It has it to the 4th, but your middle term is squared. So the x to the 4th is squared, your x squared. So that's where it becomes a quadratic. So whenever you have this problem, notice that this is going on. You could even rewrite this as a 12x squared, that's a 2, and then minus an 11x squared plus 2 equals 0. The kicker to this problem is the fact that you have a squared term here and a squared term here. That's where we're going to do the substitution. And when you do a substitution, we are going to let u equal x squared. So we're going to replace that. So we actually have a 12u squared minus 11u plus 2 equals 0. Now it looks like a quadratic that we're used to. And that's why you do it. That's what in quadratic form, a squared term, a regular term, and a whole number. We just go through this and we factor. Good old factoring. So now I'm going to break this into our two sets of parentheses. 12 You have several options whenever it comes to 12. However, notice that there is a 2 in the back. So remember, you can't have the same factors within. So I'm going to go with a 3u and a 4u, which means that 2 has to go in the front and the 1 in the back so that I don't have like terms. With a plus sign in the back, my signs are the same. They're both a minus. Now you check your outsides and insides. My outside terms are going to give me -3. The inside terms are -8. So I have -3u, -8u, and there's my middle term of -11u. Just checking those outsides and insides. It's factored, so cool. Now we use our zero factor property, set each one of those equal to 0. And solve. Add 2, divide by 3, and u is equal to 2/3. Add 1, divide by 4, and u is equal to 1/4. Now here's the kicker on this problem. Did I start with a u as my variable? No, we did not. We made the substitution. Because we made that substitution, I started my problem with an x. So you have to end your problem with an x. Sub that back in. So I now have an x squared actually equals 2/3. And x squared actually equals that 1/4. Now you can use your square root property. Remember, anytime you make the square root symbol, you always have to write plus or minus. So this is really the square root of 3 on the bottom. If we rationalize that denominator, going back to our intermediate algebra days, right? Rationalizing that denominator, I end up with the square root of 6/3. Because that 6 is under the radical, I cannot break it down any farther. And whenever you square root this side, again, you still plus or minus. And the square root of 1 is 1, and the square root of 4 is 2. Technically, how many answers do we have here? Yeah, 4 of them. A positive square root of 6/3 and a negative square root of 6/3. A positive 1/2 and a negative 1/2. What is the highest exponent up here in my problem? A 4. How many answers do we actually have? 4. That is not a coincidence. That's called the fundamental theorem of algebra. We'll talk more about that a little bit later, but pretty cool, right? Awesome.